lesson 3 in probability, and in this lesson we are going to learn how the combined events, and in this section we will deal with probability of two events happening. We have two types of events. We have mutually exclusive events and independent events. So we are going to look at, to start with, mutually exclusive events, then later we look at independent events. So mutually exclusive events, these are events whereby the occurrence of one exclude the occurrence of the other. And what do we mean by that? It means if one event occurs, then the other one will not occur. And we have an example here. When you toss a coin, you get a head or a tail. This is a head and this is a tail. So, and we normally refer to it as a fair coin. This means that if you toss a coin, that is, throw up the coin, and it runs, the top side is a head, then it means the tail will not appear. So that is what we mean by exclusive events. When one event happens, it means the other one will not happen. So, and let's have a look at also when we toss a die. Again, we say when a die is tossed, the probability of getting 2 and 5. So, like I have mentioned earlier, a die has 6 sides with the marks. One side has 1 mark, and another one has 2, like this one. This one has 3, this one has 6. So we have another side that has 5 on the other side, and another one has 4. So when you toss a die, we normally say that here the probability of getting a 2 or a 5 is equals to probability of getting a 2 plus probability of getting a 5. Because there are 6 sides, the probability of getting a 2 is 1 out of the 6 sides plus 1 out of 6 sides, which is 2 over 6, giving you a third. So that means that these are mutually exclusive events, because if you get 2, you will not get 5. If you get 5, you will not get 2. We normally use the word or, or, and when the word or is used, we add the probability. We can say, even with the coin here, the probability of getting a head or a tail is equals to, of course, when you toss a coin, you must get either a head or a tail, so it is probability of getting a head plus probability of getting a tail, which is equals to a half plus a half, which will give you 1. This shows us, like we discussed, the range of probability, that when you toss a coin, you are very sure, 100% sure, that you either get a tail or a head. Otherwise, that is why the probability is 1. So from here, let's do an example, then we look at the independent events. So this is our example 1. It is on combined event, mutually exclusive events, and we are told that die is tossed once. Find the probability of getting an odd number or 6, an even number or 5, 3 or less, at most 4, 3 or more, not more than 2. So we start with the part A of the question. The probability of getting an odd number or 6 is equals to the probability. We said when we are dealing with the mutually exclusive event, we add. So the probability of getting a 1. So our dice has the numbers 1, 2, 3, 4, 5, and 6. This means the odd number we have 1, we have 3, we have 5, or 6. So we have probability of getting a 1 or probability of getting a 3 or probability of getting a 5 or probability of getting a 6. So you realize that this is equals to probability of getting 1 is 1 over 6 plus we add. We have said the mutually exclusive event, we add 1 over 6 probability of getting 3 plus 1 over 6 probability of getting 5 plus 1 over 6 the probability of getting 6, and this should give you 4 over 6, which when we simplify we get it is 2 over 3. So that is the probability of getting an odd number or 6. We come to part B. Part B, we are told an even number or 5. So even numbers 2, 4, and 6 or 5. So we say probability of getting even number or 5 is equals to probability of getting 2 or probability of getting 4 or probability of getting 6, those are the even numbers, or probability of getting 5. So this will give us probability of getting 2 is 1 over 6 plus probability of getting 4 is 1 over 6 plus probability of getting 6 is 1 over 6 plus the probability of getting 5 is 1 over 6. So this is 1 over 6, which gives us a total of 4 over 6, and this when you simplify you get 2 over 3. So that's the probability of getting an even number or 5. Part C, we are told that the probability at 3 or less. So 3 or less is that 3, 2, or 1. So probability, we say 3 or probability of getting 3 or less. Probability 3 or less is equals to the probability of getting 1 or probability of getting 2 or probability of getting 3. So this gives us probability of getting 1 is 1 over 6 plus probability of getting 2 is 1 over 6 plus probability of getting 3 is 1 over 6, which gives us 3 over 6, which is actually a half. So that is the probability of getting 3 or less. Probability of getting at most 4. So this is a probability of getting, so this means that it is a probability of getting 4 or less. So we say this is D, probability of getting 4 or less is equals to probability of getting 4 is a probability of getting 4 or, so part D, we are told at most 4, so it means a probability at most 4. This means the probability of 4 and below. So we say this is a probability of getting 1 or probability of getting 2 or probability of getting 3 or probability of getting 4. So this is equals to probability of getting 1 is 1 over 6 plus 1 over 6 probability of getting 2 plus 1 over 6 probability of getting 3 and 1 over 6 probability of getting 4. So this is 4 over 6, which is 2 over 3. So that is the probability of getting 4 and at most 4. The other one is probability of getting 3 or more. So we say this is the probability of getting 3 or more. It is equals to the probability of getting 3 or probability of getting 4 or probability of getting 5 or probability of getting 6. So when you work out this is 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6, which should give you 4 over 6, and that should give you 2 over 3. That is the probability of getting 3 or more. Then finally, not more than 2. So this is our D, this is our E, and we use this space here for our F, not more than 2. Then it means it is a probability not more than 2. We say it is equal to, they are not more than 2, then it means the probability of 1 or 2, which is equal to probability of 1 plus the probability of getting 2, which is equal to 1 over 6 plus 1 over 6, and that will give us 2 over 6, which is the same as that. So that is an example of mutually exclusive event. So note here that when you are dealing with mutually exclusive event, we add the probability. So from here we look at the independence events. So we now look at the independence event, and we say that two events are said to be dependent if the happening of one does not influence the happening of the other. For example, if we toss a die, here we have a die and we have a coin here. If we toss a coin, we can get a head or a tail. That does not affect the outcome of the die. We can get 2, we get a head. We can get 3, we get a tail. So the two events are said to be independent. And when we have an independent event, we normally say that the probability of them occurring together is a product of their individual probability. And that is to say, the probability of event A and event B happening is equals to the probability of event A happening multiplied by the probability of event B happening. This is called a multiplication rule of probability. So I hope that one is very clear. That when you toss a coin and a die, the outcomes does not, the outcome of the coin does not affect the outcome of the die. And when we are getting the probability of either getting a head and getting a 3, we multiply the two probabilities. So let's that's what we are calling multiplication rule of probability. Let's have a look at an example, a few examples, and see how we work them out. This is our first example. We are told two fair coins are tossed together. There is a repetition here, don't worry. Find the probability of getting a head and a tail. So when you toss two coins, these are independent events because the outcome of one does not affect the other. So we say the probability of getting a head, instead of or, now here we use and the tail. So in independent event, we use the word add. In mutually exclusive event, we use or. So we separate this and say this is the probability of the head multiplied by the probability of getting the tail, which is equals to the probability of getting a head is a half multiplied by the probability of getting a tail of the other coin is a half, and this should give you 1 over 4. So that is how we work out the probability when we have independent events. Our example 2, a die and a coin were thrown. Find the probability of getting a 6 and a tail. Again, these are independent events. The outcome of the coin will not affect the outcome of the dice. So we say that the probability here of getting a 6 or a tail, and a tail, not or, a 6 and a tail is equals to the probability of getting a 6 multiplied by the probability of getting a tail. The probability of getting a 6, since we have 6 numbers, it is 1 over 6 multiplied by the outcome of the coin are only 2, so we say it is 1 over 2, and this is going to give you 1 divided by 12. So the probability that when you toss a coin you get a 6 and a tail is 1 over 12. Another alternative that we can do this is we can make a table like that. Then we have here we have so we can say this is a dice, so we have 6 pieces there, 3, 4, 5 and 6. So here is the dice, 1, 2, 3, 4, 5 and 6. So here we have the head and we have the tail of the coin. So one option is we can have 1 and the head, 2 and the head, 3 and the head, 4 and the head, 5 and the head, 6 and the head. Then we have 1 and tail, 2 and tail, 3 and tail, 4 and tail, 5 and tail, 6 and tail. And because we are told to get the probability of getting a 6 and a tail, you can see here it only occurring once, a 6 and a tail, out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So its probability of getting a 6 and a tail is only occurring once out of 12 outcomes. So you still get the same using that method. So our example 3. 3 types of bulb, A, B, and C, have different probabilities of burning out before 6 months, as shown below. So we have a bulb A, probability of burning out before 6 months is 2 over 5. B is 1 over 5. C is 2 over 9. So find the probability that all the bulb will burn out before 6 months. So this or burnout is equals to the probability of A burning and B and C. This is because they are independent event. If bulb A burns, it does not necessarily mean that bulb B will burn. So this will be probability of A burning multiplied by probability of B burning multiplied by probability of C burning, which is equals to 2 over 5 multiplied by 1 over 5 multiplied by 2 over 9, and that should give us 4, and then we have 4 9 45 25 times this is 225. So that is the probability. Then part B, the probability that the bulb will burn after 6 months. We say that the probability of an event happening that is burn after 6 months is equals to 1 minus the probability of them burning. So burn. So this is equals to 1 minus 4 over 225, which is equals to 221 over 225. So that is the probability that the bulb will burn after 6 months. We subtract the probability that they will burn before 6 months. Our example 4, a bag contains 10 white balls and 8 green balls. If 3 balls are drawn from the bag, one after a time, find the probability of drawing a white ball followed by a green ball and finally green. Now, part A without replacement and part B with the replacement. So in this case, we say that since we are drawing the ball one after the other, they are independent events. So we say probability of getting a white ball and a green is equals to, since it is with the replacement, it means that it is a probability of getting a white multiplied by probability of getting a green and multiplied by probability of getting a green one, which is equals to, the total number of balls are 18 and we have 10 for 10 white, so that is 10 over 18 multiplied by 8 over, since we in the first place we are not replacing, so it will remain 17. You multiply by if you draw one, so you have 7 over 16. So once you simplify this, then you should get by 8 is 2, by 8 is 1, by 2 is 1, by 2 is 5, and this should give you 35 out of, when you multiply this, it is 306. 306. I hope that is correct. 8 times 7 is 56. 306. Here we come to part B. Part A, that's part A, part B. Then part B, we are told it is with replacement. So the probability of getting a white and a green is equals to the probability of getting a white multiplied by the probability of getting a green multiplied by the probability of getting a green, which is equal, since we are replacing, it means the number will remain the same, multiplied by 8 over 18 multiplied by 8 over 18, and that should give you, when you multiply that, we can simplify this. By 2 is 4, by 2 is 9, by 4 this is 9, that is 9. So this gives us 80 out of 729. So that's how we work out that probability, and that brings us to the end of, or we do one more and then we wind up the lesson. Our example 5. 5 men and 3 women are in a queue to see a doctor. Find the probability that the first 4 people called in to see the doctor will be man, man, woman, and man, in that order. So the second one, the first 4 people called in to see the doctor will be men, if all the patients have equal chances of seeing the doctor. We start with our A. Our A, we have probability that we have a man followed by a man followed by a woman followed by a man, and we have 5 men and 3 women. So probability of getting a man is 5 over 8 multiplied by, once you take in 1 man, then you have 4 over over 7 multiplied by the women remain 3 over 6 multiplied by now 3 over 5. So when you work out that using your calculator, you get the probability is 3 over 28. We come to part B of the question. The first 4 people called are men, so you have 5 over 8 multiply, just say, so we say probability is a man and man and man and man. So this is equals to 5 over 8 multiplied by 4 over 7 multiplied by 3 over 7 multiplied by 2 over 7. And when you compute that, not that, this you multiply 3 over 6 multiplied by 2 over 5, and when you compute that, you get the probability is 1 over 14. That is when you simplify. In conclusions, since we were discussing independent event, always remember to differentiate between mutually exclusive event and independent event. And always remember, when you are dealing with independent event, we normally multiply the probabilities. When you are dealing with mutually exclusive event, we normally add the probabilities. In mutually exclusive event, we use the or, the word or. When you are dealing with the independent event, we use add. And when you use or, we add. When we add, addition. When you use the word add, we multiply. So you should be able to differentiate. And that brings us to the end of that lesson. I hope you have enjoyed watching the lesson. If you have any question, you can always forward it through a comment, or you can send it to me in my WhatsApp. I will always be able to assist. So we will now move to our last session, and a very interesting part of probability. In fact, it is a part that I enjoy most, the tree diagram, which is a very interesting part. So I hope you'll be able to watch it here.